Hello, listeners. Today, Ravi and Jam speak with Marc Borrett about a very hot topic after the blackout in Spain, grid inertia. Marc is the CEO and co-founder of Reactive Technologies, whose services to grid operators are very related to the trilemma and the transition to renewables. Marc previously co-founded Innovision Research and Technology, which was acquired by Broadcom. Ravi, Jose, over to you.
Thank you, Ava, and welcome, Marc, to the Unlocking the Energy Trilemma podcast.
My pleasure. Thank you for inviting me, Jose.
Thank you, Marc. Thanks for joining.
As we do with all our speakers, I'm going to ask you to share a fact around the energy trilemma and reactive energy and measuring and monitoring power grids with this topic. What do you bring us?
It will be quite a specific fact. If we think of the energy transition, which is really a sustainability objective, it can often get made a little bit too simplistic. Typically, it's about building more renewables and then connecting more renewables, which means it's a bit about permitting and then a bit about building out transmission. But those are they don't fully show the scale of the challenge. And the third part, which isn't talked about, is really about how you then run a grid on 100% renewables. And where we come in is really helping grids identify new control parameters that will help them make this sustainability jump forward. And the fact is that if you can measure inertia, which is the stability of a grid, we can effectively unlock up to 30% more capacity for more renewables to go on the grid and still maintain a secure and resilient grid. And so we really see that these kind of measurement technologies are really things that can unlock this additional capacity, support the trilemma in a positive way because they're cheaper to build, they're quicker to build, and they help make better decisions all around. And in the UK, we've been running our inertia measurement system we're in our third year. We are saving in the UK about 18 million tons of CO2, which is about 5.5% of total UK CO2 emissions. So if you can measure the right thing, you can make a huge impact, positive impact on the energy trilemma.
Mm-hmm. Marc, on April 28th this year, a massive power outage swept across Spain, Portugal, and parts of southern France, affecting close to 50 million people. And as the blackout was said to be one of the most disruptive in recent history, and it is said it stemmed from a sudden collapse in grid stability triggered by voltage and frequency disturbances that overwhelmed a lot of systems and protection protocols. So in that context, the event obviously highlighted how quickly frequency instability can escalate in high renewables, low inertia grids. What role can stabilization technologies play in preventing or containing similar events?
Yes, it's a very good question. Obviously, no one wants these things to happen. And initially it wasn't, and it still isn't really clear what the actual causality was. We know it's not a cyber attack. The Spanish government confirmed that yesterday. We know, as you say, that there are some big oscillations happening on the whole European grid. Specifically, there were two. And the second one seemed to create a loss of generation. About 2 gigawatts came off. That caused over voltage, which then further tripped off more generation. And at that point, the Spanish or the Iberian Peninsula lost synchronization with the European grid, and frequency dropped to 49.5 hertz, and then load shedding kicked in, but it wasn't able to rescue the whole system. So I guess from our perspective, how could that have been alleviated? Some things, and until we really know the facts, it's very hard to be actually specific. But if you think about a grid, you wouldn't think of running a grid without measuring voltage or current. And I think what we're now seeing with how grids are transitioning and having much more inverter-based renewables on there, having less stability, as you talk about, Ravi. If you can measure the stability behavior of your grid, then it goes to the fundamentals of everything, because knowing how your grid is actually behaving means you know your operational limits. When you have enough stability and when you don't have enough, where to invest to support and re-strengthen parts of your grid that you perhaps wouldn't necessarily have seen had weakened if you simply are only able to model your grid. And as grids become more complex, as they change more quickly, modeling and system models find it very hard to keep up. So providing yourself with a measurement foundation helps you have a much better understanding of your grid at that operational level, but also that future planning level. We see that it becomes part of the toolkit. It's a new tool, but it becomes part of that toolkit to help manage what is a much more complex and fast-moving grid than has been traditionally the case with fossil generation-based grids.
Okay. One of the things related to the blackout is potentially the inertia ratio in Spain. Now, in Spain, we don't have a minimum requirement of inertia. In other places, in similar situations, such as in Ireland, iGrid and Sony are running the grid with a minimum relationship between reactive power and active power. I think it's 0.23. That puts a threshold either of the amount of renewables in the mix and the, let's say, the need of other tools such as condensers or more combined cycles or whatever. I think monitoring the grid in this point is key. And I understand that every grid operator in the world should have a kind of minimum threshold to ensure that they can run the network properly. Is that correct?
That is. So there is a difference, I think, when you look at, say, the European synchronous grid and you compare it to, say, the UK. So what we've seen in the UK is effectively an island. It has some connection with other grids and certainly some of the European grid, but those are DC-based connections. So they're not providing synchronous inertia or support to the UK and vice versa. But again, if you go back to the trilemma, and you go back to the sustainability target, what does net zero mean? It means that you have to transition your grid to run predominantly or potentially 100% exclusively on renewable power. And that renewable power does not contribute stability. So you have to find a way of managing this transition, and the only way you can do it, and this is what we've now seen with National Grid in the UK, is this continuous, and it's not just monitoring, it is direct measurement of the inertia, allows a floor to be set, which then all your frequency response services are then tuned to. So the type of frequency response that you best need for your grid, because now you can measure how it behaves, the quantity, the speed, the duration, all of these things you can now tune to be specific to the way your grid operates, which means they'll be maximally effective for you. But I think fundamentally, you have to build up a real strong data set, empirical data, to allow you to start to reduce that flaw. So you have to find a way as a grid operator to maintain the security of the grid, keep the lights on, but at the same time be able to operate your grid on lower and lower levels of inertia on it. And the only way you can do that is really through this direct real-time measurement. And that's what we've seen in the UK. And I think that does seem to be more and more understood by grids that are facing these high renewable contributions on their grid, that they have to move to this kind of way of understanding their grid through direct measurement.
Mark, as AI-driven loads, they meet in places like West Texas and Virginia and parts of US, how AI loads are colliding with low inertia renewable heavy grids. What are the implications? What are you seeing in Europe and the United States with respect to AI driven loads and whether they are challenging for the grid?
The implications, Ravi, I think are really significant. So these are energy or grid connected assets that are being built at a larger scale and are being deployed at a faster rate than conventional large-scale generation assets. As you've highlighted some of the locations in the US where this is really, I think the US is obviously defining this hyperscale solution in the market for data centers. We're seeing data centers being built over 3 gigawatts in terms of energy demand. Incredible sized assets. But even though they're connected to the grid, they don't behave like conventionally connected grid assets. And in January this year, we saw for the first time NERC issue an incident review where they flagged to grid operators this growing risk of these very large loads suddenly disconnecting from the grid through just normally cleared faults happening on the grid. So the data centers have got a different sort of power quality threshold to the utility or the grid operator, and that does raise the stakes for maintaining system security, because in the control room of a utility, they need to manage conventionally to their largest loss. And typically that has been your largest generation asset, which has typically been a nuclear site. Now, however, when you have data centers being built that are bigger than nuclear sites, and they are often co-located, so they will typically see the same voltage issue, a number of them rather than just one. You, as a grid operator, now have to cope with an n minus n. You have to now run scenarios potentially that a number could disconnect. But again, that's through normal operations that you wouldn't see as a potential risk. So they definitely raise the challenge of maintaining system security going forward.
Mark, you've mentioned nuclear power plants. How do you foresee the impact of a potential closure of nuclear power plants in countries such as Spain? Do you think that this is something that we can cover with other measures, or the inertia will be impacted drastically and in some way it could delay the implementation of renewables?
Well, so nuclear power obviously has got a challenge, waste element of it, but it is synchronous. You are creating power through spinning a turbine that is then producing the electrons out the other end. And that synchronous contribution is really important. But again, if I would go back to where I set out earlier, there is a route to running and maintaining secure operations from grids with very high renewables. But you need, as a grid operator, a modern toolkit to be able to do that. You are moving from running a grid that feels like running a steam engine that is nice and heavy and can run through anything and you can ride it through and you've got lots of time to deal with things, to operating a grid that feels much more like a motorbike. You have a big throttle and it will move very quickly and it can lose balance quite quickly. But if you have all the visibility, if you have a really good dashboard of what's going on, you can stay upright and you can keep everything moving and you can drive faster potentially. From our perspective, it is part of that transition. Whether nuclear has to go or stays, it's really about the synchronous plant. And there is definitely a way forward to run renewables through grids and maintain that security. You just have to have a different toolkit to be able to do that.
Mark, you raised some very compelling points. Do you believe that real-time inertia measurement would actually become a regulatory requirement in different markets? Is that something that you're working towards? Is that something that is likely?
Possibly, Ravi. I think there are some evolutionary steps. I think the first stage is it is becoming understood as best practice. So often regulatory follows best practice rather than define best practice. So we're starting to see that it becoming recognized as a best practice tool for grids to adopt and use and allow them to safely manage that transition. But regulatory is definitely the destination, because often with regulatory you have the financing side of things intimately connected to that regulatory environment. And the regulatory environment is very much skewed to big capex, isn't it? And it's about how you invest in transmission assets and substations and all these sort of large hard assets. But it often doesn't allow grids to make investments in these sort of toolkit type of things. Those often aren't big enough in terms of the capex side to get the attention or the interest. But actually, if you focused it on the outputs, that would maybe change people's views, that you can much more quickly affect positive change and secure the grid and make it more resilient through investing more smartly in tools rather than just physical assets that still don't necessarily solve for the complexity of the challenge that is ahead.
It sounds fantastic, Mark, all the comments you've made. But before closing, I would like to ask you, as any other of our guests, if you had a magic wand, what would you do to unlock the energy trilemma?
I think, Jose, I did think about that question, and I think it just goes back to the last point, the regulatory one. I think every grid wants to do the right thing. They carry a huge amount of responsibility. You just have to see how society relies on consistent, reliable, quality power. It's just like air that we breathe, and suddenly losing it is so difficult to manage. But at the heart of it is that regulatory environment, and the regulatory policies have to allow grids to not just experiment, but to implement new things which don't fit the traditional model of building large capital assets or building high voltage lines. Those things are needed, but there needs to be space to allow grids to make these more softer investments, which really will make the difference in this day-to-day, but also in the long-term planning. So very much that would be the wand that I would really like to wave, because I think it would really move the needle in a very quick way and in the right way on every trilemma metric would be positively influenced by it.
Thanks very much, Mark. It's been an excellent conversation. I'm sure our viewers are going to like your views and perspectives, and especially given what we have seen recently happening in Europe and the kind of disruptions that they have caused. Once again, thank you very much, and we look forward to keeping in touch. Thank you.
Yeah, my pleasure, Ravi. And same to Jose. Thank you both for having me.
We hope you liked this conversation. Follow us on LinkedIn or subscribe for free to the podcast on the platform of your choice, Spotify, Amazon, YouTube, or Apple. Because in the next episode, Ravi and Jam will speak with another expert in the industry to unlock the energy trilemma.